Hey everyone, in this video, let's take a look at question 53, maximum subarray on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we are given an integer array nums, and we want to find the subarray with the largest sum and return that sum. Let's take a look at the examples here, and note that we're returning the maximum sum, not the actual subarray. So take a look at the examples over here. And first thing we actually notice is that the array has negative values. If it did not have negative values, well, then the answer would just be the total sum of the array, right? Because it would just keep increasing or potentially like remaining the same if you have like zeros. But looks like we can have negative values here. So we can't even use that approach to begin with, but it's just one thing to note. So let's take a look here. So it looks like the subarray 4 minus 1, 2, 1 gives us the largest sum of 6, and we'll see how we come by that. We can see here that if it's just like one item, well, then that's the maximum sum. We can see that the maximum sum can also be the entire array, even if the array contains like a negative element. So that's one thing to notice. So how might we go about like solving this, right? Like what is something we see here? Well, in these types of problems where they ask us to find the maximum or the minimum over like an entire array, right? Then it's often helpful to pick a particular index, like let's say index I, right? And note that we have the answer up till this index here, and we want to basically know whether we can include this index, index I, in the answer, or we cannot include it in the answer. So what do I kind of mean by that? Well, let's take a look. Let's take a look at this approach here. So initially, as we mentioned, the first answer has to be -2, right? It has to be the first element of the array. Now, when we arrive at a new answer or a new index here, we have two choices, right? Either we want to include this as part of our continuous subarray, or we don't want to include it. Maybe this is like its own subarray, and then it goes forward. So what can we do here? Well, we note that the answer so far is -2, right? And if we want to include it, then we have to do -2 plus 1, which would give us a -1, right? So then if we include both of these items, then the subarray sum would be -1. But if you really look at this, then why would we include -1 when we can just use the sum of 1? Why don't we just start a subarray here, right? Why are we including this one, which has sums of -1, when we can just start off here with sum of 1, right? So in this case, we have two options. Either we include the 1 or we don't include the 1. If we include the 1, we add it. If we don't include the 1, then we don't add it. So here, actually, the best sum would just be 1, because then it's just greater than the sum of what was good so far and then plus the existing one. Let's take a look here. 1 and then -3. Well, here, the best sum would be -2, right? So not best sum, but the sum so far would be -2, assuming like we consider this case over here. Now, notice that -2 is greater than -3, so it wouldn't make sense to put -3 here, but we would take this -3 here as part of this sum here. But note that our best sum so far has just been this 1, so maybe we can keep track of maybe something like best sum. It's just this one subarray here, which is just like the value of 1. But the sum so far is like these two values here, right? So maybe we can do like so far is going to be 1 and then -3. And that gives us -2. Now, when we arrive at this 4, we are again faced with the question, do we want to include this 4 or do we not? Well, if we want to include this 4, then it will be included in this subarray here. So then the answer will be 1 minus 2, and then we add in the 4. So the -2 plus 4 would give us a value of 2. So we can either do something like this, right, to give us a value of 2, or we can just take 4 in itself, right? Because 4 is actually greater than the subarray sum we can form by actually including it. So why don't we just take 4 here? So the best sum at this point would actually just be 4, and now we just actually start off with 4, right? Now similarly here, the -1, well, -1 and then 4, do we want to include it? Well, we should include it, right? Because if we don't include it, then we have to start off at -1, this subarray here, which is not better than the 4 one. So we will include it and we will get a sum of 3 now. So now so far, it looks like our answer is 4 and then -1. So this is the subarray. And then so we get the value of 3. But notice that the best sum so far is still 4, but we are just calculating the subarray sum as to be 3. And then here, what can we do? Well, then here we have a 2, right? And so we can add in the 2 or we cannot add in the 2. Let's say we want to add in the 2, well, then we'll get a value of 5 here. So now, if we add in the 2, we'll get a value of 5. And notice that now it's actually greater than the best sum so far of just 4. So now here, it's actually something like this that will give us the value of 5, right? Then we want to add in one more, and we can see that this one's actually positive. So we can add in one more to get 6. It looks like it's actually the best answer so far. Now here, when you arrive at the -5, so this one will be 6. When you arrive at the -5, again, we either include this or we don't include it. If we want to include it, well then our sum becomes 1, which is not the best sum, but now the sum so far, if we include the -5, will be 1. But it's better than at least taking like -5 and starting completely in the negative, right? So here it'll be 1. And then finally, we add in this 4 and we can get a 5. So now, if we add in the 4, we'll get a sum of 5. But so far, we can see that the best sum has been 6. So that's the approach we will take. And let's go ahead and write this in code. And I think it will make more sense that way. But basically, so the best answer, right? So for our best answer, we can just say is nums at 0, right? And then we also need a way to basically figure out like what is like the last element, right? Like the previous sum, like the previous sum as part of the subarray. So we can take that one. So maybe I can just actually use this. So best sum, and then we can do so far. Initially, both of these will be the same, right? And now what we can do is we can loop through our array. And notice I'm starting on the first index because we already processed the 0th one. We've processed like the initial one. So now here I have the choice. Either I want to include this index here as part of my like so far array, or I want to start so far once again like brand new. So what I can actually do is I can do so far is equal to what? Well, here I've like made it equal to the array itself, but really we just need it equal to the value, right? Like the sum. So I can do so far is equal to the maximum of what? It should be so far plus nums at I, right? So here I am including the index, or I will just keep the index in itself. So here, instead of something like this, I would just keep this index here. So that'll be nums at I, right? But now that only updates so far. It does not update our best sum. So now we also need to update our best sum to be the maximum of best sum and just so far, right? And in the very end, we'll just return best sum. And that's all there is to this question. There's a medium question, but if you really think about it, all we are doing is just going through and then calculating the result as we go by. So now let's just go ahead and click submit, and we arrive at our answer. Perfect. So this is a O of n time algorithm. You can see that you can really use this. You can think of this as like dynamic programming, but why use extra space? We can just like use two kind of variables over here. And so yeah, like O of n time, and then for space, it's pretty much O of 1. Okay. Thank you for watching.